Okay, now for a case where you have 180-degree phase difference between slits, okay, if you had 180-degree phase difference between slits, slit 1 would have, if slit 1 is at 0 degrees, then slit 2 is at 180 degrees, slit 3 would be at 0, slit 4 would be at 180. And I've got the circle around this thing, okay, this part corresponds to 180 degrees between slits. Now, if you got 90 degrees between slits, then what do you have? Well, slit 1, if at 0 degrees, slit 2 could then be at 90 degrees, slit 3 at 180, slit 4 at 270. Okay? If you add these vectors, okay, if you add the phases of these 4 waves, okay, the waves coming from the 4 slits, when you add vectors, you add them head to tail. So head, and then put the tail of this one at the head of this one. It's going to go up like this. Put the tail of this one at the head of that one. Well, here's what you're going to get. First, second, third, fourth. What do they add up to? They add up to 0. Okay, putting the vectors head to tail, they add up to 0, indicating that if you do have 90 degrees between your slits, you're going to have destructive interference. Okay, and this is going to happen no matter in what direction the slits are. Okay, whatever the direction of this slit, this one's going to have to be 90 degrees from that direction. So as the phase changes in time, this vector will, again, go around a complete circle for every cycle. But this is always going to be 90 degrees from this one. This is always going to be 90 degrees from this one. This 90 degrees from this one. So, the picture might look like this at some later time. But you're always going to have these vectors adding up to 0. They're always going to end up back where they started. Okay. If there's 270 degrees between slits, what's it going to be? Well, it's here, then here, then here, then here. You're going to have the same thing. You've got to start here. Well, you've got to start here, go over here, down here, here, here. You're back where you started. Okay? So that's pretty much the idea of phasor diagrams. Now, there's one problem in your problem set. And I mentioned in class, I found phasor diagrams to be pretty hard to understand when I first encountered them. I didn't have a detailed explanation from class, and I had to pretty much figure it out myself. But of course, when I figured it out, after, I don't know if it was 90 seconds or 90 minutes or 90 days, it was more than 90 minutes. But it wasn't 90 days. Okay, this is not an easy thing to understand. So hopefully this explanation will help you understand what's in your book and apply it to the one problem I believe I assigned that involves phasors. I also mentioned that, just a little irony or whatever, you talk about phasors, you think back to Star Trek. That's where phasors were first introduced. And it was a different kind of phaser, but just coincidentally, Leonard Nimoy died a couple of days ago. His funeral was yesterday, I believe. And lived a great life, lived long and prospered. Let's see, can I do that thing? Yeah, there we go. Okay. For Leonard Nimoy. Okay.